Stop animal abuse. So recently there was a case around our area where a monkey actually escaped. Like, it somehow managed to escape from the zoo, and that monkey essentially escaped and started touring around, visiting different sectors. And surprisingly enough, it was a chill monkey, like it didn't harm any civilians, do nothing. And matter of fact, it even came through to our house. But the sad part is some people decided to shoot this poor boy down, and I believe he got shot 7 times, but hopefully the monkey recovers soon. I believe he's in like some critical care center, like a vet place. So prayers up for the monkey in my area. And yeah, let's just get right into the physics video. Now, before we start, I've already made an in-depth video of difficult MCQs, so this is going to be a continuation. Here we have a diagram that shows a ball of mass x 0.15, and it's moving with a velocity of 2.1. There's another ball y, and that is also moving with this much speed in the opposite direction. Now here we have the diagram showing the two balls. So what is the mass of ball y? Now this question is very typical of law of conservation of momentum, which states that if we know the momentums of all the objects before a collision and we know the momentums of the objects after the collision, like the total, then we can just equate them together, we can equalize them together. So we know that momentum is usually represented with a p, which is equal to mass times velocity. Now we need to be careful over here because a very common mistake that students make is they forget that velocity is a vector, which means that it has a direction. So with that into account, let's see what the equation might look like. Now it should look something like this before the collision, and keep in mind that since x velocity direction is in one side and y is on the other side, so we know that to represent direction we use the positive and the negative signs. So we can perhaps label this as a positive direction and this as a negative direction. So over here we can see that vy will actually be negative in nature. Similarly, we have after the collision, and that will look something similar. Just keep in mind that whatever we are doing, we need to be careful of the direction of velocity. So now that we've done this, we just need to equalize them and put in the values, and we should get to the mass of ball y. So we should get to a final equation that looks something like this, where the before the collision momentums are equal to the after the collision momentums, and then we simply substitute the values. Now the confusing part again about here is the direction. So we know that the velocity y was moving the other way, opposite to velocity of x. This is why we're going to denote this with a negative sign. Similarly, in the second after collision, we can even see that x now moves in that negative direction. Therefore, once we do this, this is just simple maths, and we should reach our answer as 0.35. So the answer of this question will be C. Now, two beakers are filled to the same depth, one with oil and one with water. So the density of water is this, and the density of oil is that. So where is the pressure the greatest? Pretty simple. We know that there's only one equation linking pressure and fluids, which is pressure is equal to rho, which is density of the liquid, times g, which is the gravitational field strength, and we have height. So clearly, the deeper something is, the more the pressure it is. Like if you think about it, if you like go deep under the water, ears start hurting and like you feel like you experience the pressure essentially. Same concept over here. So it cannot be C or A, it has to be one of these two. Similarly, we can see that pressure is actually dependent on density, and that also makes sense. Like for example, oil has less density, which would mean that maybe in this much volume 3 particles are pushing down on you. Over here, water has more density, which would mean that in the same volume 4 particles are pushing down on you, meaning that you'd experience more pressure. So with that logic, the answer should clearly just be B, because it has more height and more density. Alright, moving on, here we have a diagram that represents the particles in 3 different substances, P, Q, R. Very simply put, Q is going to be a solid, R is clearly a gas, P is clearly a liquid because of the intermolecular forces that you can see. Anything that is tightly packed, that's a solid. Pretty self-explanatory. Anything that is widely spread apart is a gas, and in between is a liquid. So the samples have equal volumes and the same temperature, and they are heated, and there is no change of state taking place. So over here, what is interesting is they increase the temperature of the sample, but there is no change in the state. So which row shows possible percentage increases in volume for the 3 samples? Now this question is not that difficult, but it's a bit conceptual. Over here, we know that what do solids do? Do they move about? No, they vibrate around their fixed position. So if you were to increase the temperature, the most it would do is just go back and forth in its own position, which would mean a very minimal increase in percentage volume. So we would assume that Q does not have the largest percentage change. It must have the smaller sides of the percentage change. Now similarly, we see that gas obviously will have the largest amount of change, because as you increase the temperature, the gas molecules move further apart. There are no bonds holding them, so their volume being expanded is limitless, essentially. Not limitless, but like it's going to be a larger amount. So we can clearly see that the examiner knew that we would have the same thinking process. That's why they put 7.2 with the lower range values. We will have an in-between answer. It's going to be higher than Q but lower than R. And we can see that for that to occur, it has to be C over here. Okay, next part. In a circuit, two identical lamps are in parallel, and the parallel pair of lamps is in series with a resistor and a battery. Okay, so before we even like read this question, let's just draw this out, because I like to like visualize everything. I like using that word a lot. So this is like the most probable design of the circuit. We have two lamps in parallel connected with this singular resistor in series. Now the battery does this much joules of energy of moving this much charge around the circuit in time t. So this right off the bat, we know that if we have energy and we have charge, that is the key formula for voltage. So now we can calculate the voltage. I don't even want to do the rest of the parts because, you know, we can just find the V already. So that'll be 120 divided by 50. So once we do this, we should get our value as 2.4. Now in each lamp, 40 joules of work is done by the charge that passes through it in time t. Interesting. So the EMF of the battery is E and the potential difference across one lamp is V. Now EMF is the initial potential difference that is given to the charges moving, and that is obviously going to be 2.4 because that is what we calculated in the beginning. So we can ultimately rule out option C and D. Now we just need to find the value of 1V across a lamp. Now what is the rule for parallel circuits? If you guys remember, whatever the voltage is, these red arrows, the voltage always remains the same. It doesn't split. But what splits in the parallel circuit? It's going to be the current. Now, how much of the current actually slips? So we know that in total there are 50 charges, 50 C's, coulombs, okay? And we know that over here, the charges actually do split. The current is divided according to the resistance. Since these are identical resistors, we can say that the current along this one section would be roughly 50 coulombs divided by 2, which is going to be 25. So 25 goes here, 25 goes here, and then they reunite again over here to form 50, which is going to pass through this resistor. Now, one other thing that you guys also should know is that in the question, it is mentioned that 40 joules of work is done by the charge that passes through the lamp. So V would be equal to E over Q, which is again 40 divided by Q, which is 25, and that amounts to 1.6. So our answer over here should be B. Okay, look, my hair was getting a bit annoying. A stone is thrown vertically upwards at a speed of 5, and all of the energy initially in the kinetic store is transferred to GPE. Now, and it reaches its maximum height. Now visualize this. You take a ball, you throw it up. When it reaches the maximum height, the speed becomes 0. Like if you think about it, we have a ball, you throw it up. At this height, the maximum height, the speed is 0. And then it falls back down. So which equation gives the maximum height? Now the question gives you the answer because the question states that all of the kinetic store is transferred to GPE. So we can say that KE, which we threw the ball with, that amount of energy is going to be equal to the GPE that it reaches when it is at this height. Because at this height, there is 0 kinetic energy because kinetic energy is dependent on V. Now over here, we see that M and M can be cancelled out because they are common terms. And now we're just left with V squared, half V squared is equal to GH. Now we want to find H. So H is going to be equal to V squared divided by G. And then we also have the half over here. And if you were to like put this all in together, it would look something like this. Height is equal to V squared divided by 2 times G. And the value of G is what? 9.8. So we should find something that has the speed at the top. Just like over here, we see that 5 meters per second. So it should be this. And also we should see that the G is being multiplied by 2. And that is over here, that is going to be C. So hopefully this is clear. Then we have a diagram shows a circuit for a potential divider. What is a potential divider? Potential divider is essentially a circuit that we have which consists of more than one resistor. And the main function is to basically divide the voltage amongst the resistors. And you can like vary the voltages if you want. And there's like a bunch of different setups for this. So which equation is used to calculate V1? Now what do we know about series circuits? Series circuits have constant current. Since they have constant current, can't we say that the current going through R1 resistor is equal to the current going through the R2 resistor? Can we not say that? So since these currents are equal, we also know that V is equal to IR, very famous equation. And if we rearrange this, I is equal to V over R. So we can simply say that the resistance 1 has a voltage across it, which we can denote as 1, and the resistance of it, which is also 1, is equal to the current in the resistor 2, which is going to be V2 divided by R2. Now that this is clear, we just need to rearrange the equation for V1, and that is going to be V1 is equal to V2 times R1 divided by R2. This should give us the value as B over here. Moving on, a sample of radioactive material has a half-life of 20 minutes. Half-life is what? Is the time that it takes for something to decay to like its half amount. So over here, if let's say for example we have 100 grams of something, after 20 minutes this radioactive thing will become 50. After 20 minutes it's going to become 25. So the question is, which statement is correct? Now before we even dive into this question, let's just make like a general outline. Let's say that originally we have X amount of substance. Okay, after 20 minutes what's going to happen? This X will become half the amount, because that's what half-life is. And after another 20 minutes it's going to become what? Even more half, which would be X by 4. And after 20 minutes we would see that this becomes X by 8. So let's go over these. I like to start from option D. I don't know why. So after 120 minutes, a sixth of the radioactive material remains. So this is 20, 40, 60. So we can see that this is not correct, because if it was 6, it would be somewhere between X over 8 and X over 4. Because if you keep going, this might reach like X by 16, which isn't true. So we can rule out D. After 60 minutes, an eighth of the radioactive material is remaining. So we can see that 20 minutes, 40, and then 60, we're going to have eighth of it. So this should be the answer. But let's go over the other answers as well. We can see that after 40 minutes, all of the radioactive material has decayed, which is not true. And after 30 minutes, less than half of the material has decayed, which is also wrong. I mean, more than half has decayed. The car is driven from rest on a long straight road. The car engine exerts a constant driving force. And then we have a horizontal force acting. So we have two forces: driving, resistive. Now this question is very similar to skydiving. So if you guys have done that, then this would be a piece of cake. Why does the car eventually reach a maximum speed? Why is it that when someone falls off a plane, why do they reach maximum speed, which is also termed as terminal velocity? The reason is because for there to be maximum speed, that means that the speed, like for example, it's 50, it stops there. It doesn't increase or decrease. For that to happen, the acceleration needs to be 0. Why does the acceleration need to be 0? Because acceleration is the change in velocity. So if the A is 0, that means that after 1 second this will not change, after 1 second this will not change. So we can see that the acceleration always remains 0. Now that we have this in mind, how does one achieve 0 acceleration? Very, very popular equation. Second Newton law, resultant force is equal to mass times acceleration. And we can clearly see that since the mass of the car is constant, we can like clearly negate this. Force is proportional to acceleration. So for acceleration to be 0, force has to be 0. So these are the conditions that we need to apply. So over here, we need to make sure that Fr is 0. What is Fr? Resultant force is all the forces acting on one body. We have this box, we have a bunch of forces. What is that one force that represents all the forces? Like for example, you are playing tug of war with like your brother or something, and then you are stronger. So you're going to pull, and like logically there are two forces acting, one from your brother's end and one from your end. But in total, when you add those forces and combine them, it's going to be towards you. So that is the resultant force. Over here, we need to make sure that whatever force is on the left side, it's equal to the force on the right side, so they cancel out and the Fr becomes 0. Now with that in mind, let's go over the options. Enough yapping. We can see that the resistive forces should increase or decrease. They should surely increase because the driving force is going to be constant, so the resistive forces need to slowly catch up with it. And they're going to increase to make the acceleration of the car 0. The answer should be D. Okay, the diagram shows image of a clock. So what is the actual time? So what does a plane mirror do? I'm not going to waste time on this. Whatever image you have, it's going to be inverted. So this arrow actually is going to be right over here, which is, if this is 6, this is 7. And then we're going to see that this handle should be towards this side as well because it's inverted. You have this image. Get what I'm saying? So this should be C715. Now this is a very cute question. I actually like this a lot. The diagram shows a quantity of gas trapped in a cylinder. Have you guys seen those hydraulic press like satisfying videos? Like those are kind of cool, you know, especially the ones they do with like those slime balls. The piston is pushed in slowly and the gas is compressed. The temperature does not change. Which graph shows the relationship between pressure and volume? To test between pressure and volume, you need to make sure that the temperature does not change. Now that the temperature is constant, we can easily compare pressure and volume. So pressure and volume have an inverse relation. What that means is they don't like each other. If P is increasing, V will be like, no, I'm not increasing. So it's going to decrease. And similarly, if P were to decrease, then V would be like, you know what? I'm going to increase this time. Now, in maths, if you do maths, then you will know what an inverse graph looks like. A directly proportional graph looks something like this, where the line passes straight through the origin. But an inverse graph always looks like B. It's going to have this weird shape. So you might be like, why does it not go downwards? I don't know. I was the guy who made maths, man. Now, this is a very common question. It's important that you guys pay attention. A metal resistance of wire length L and cross-sectional area A has a resistance R. What is the resistance of a metal wire? Okay, we know that the length is 2 times the original length. So let's just say we have a wire over here. It looks something like this. Now, this new wire is going to have 2L and half the area. So it might look something like this. The cross-section area is smaller, but it's 2 times as long. Now, what is the significance over here? We need to know those relationships again. We know that resistance is directly proportional to the length, which means that if you have a longer wire, there's going to be more resistance, and that makes sense as well. And similarly, the resistance and area relationship is inverse, and that also makes sense. Like, let's say you are driving a car and like you go into a tunnel which is like really narrow, so it's going to be harder for you to pull through if there's like cars ahead of you, and similarly it's going to take longer if it's a longer tunnel or canal, as you can see. So over here, since the length increases by 2 times, resistance also increases by 2 times. So if you have R over here, the resistance right now should be twice the amount. Similarly, the area also halves, the resistance doubles. So we're going to see times 2, which should be D. Now this right here is something that separates distinction holders from A stars. Like, you know how you have like these levels in video games, rookie, noob, pro max, blah, blah, blah. So usually I would say that A star people are like pros and distinction level holders are gonna be these guys. So try attempting this question on your own at first. Nope. The diagram shows 2 circuits. Each relay is normally open when there is no current in the coil. Now, to understand this question, we first need to understand what a relay is. Relay is quite simply, we have a circuit, we see cells, we see a bunch of resistors, just put them in there, you know, might come in handy. And what the main function of a relay is, that it has a coil, a solenoid, which kind of acts like a magnet. So when there's current that passes through the coil, it's going to pull this switch, which might be magnetic, okay? And once it pulls the switch, we will notice that the switch is gonna close, and when the switch closes, current can actually start flowing through the second circuit, and this would probably light up the bulb over here. Similarly, if we turn off the coil, we're gonna see that it loses its magnetic ability and the switch goes back to its original position, thereby opening the circuit. Now, if you understand that, then this question should be easy. Which environmental conditions will cause the LEDs in circuit 1 and 2 to both emit light? So you gotta know that at the end of the day, light is kind of proportional to the power given to it. The more power you give a light bulb, the more it emits light. And power is also kind of proportional to voltage because P is equal to IV. So we can see 2 circuits. We can see one with a thermistor, which is going to be sensitive to temperature, and a light dependent resistor. So an LDR functions in a way that if there is more light, its resistance becomes less. And a thermistor functions in a way that if there is more temperature, the resistance becomes less. So we see that the current will actually flow in this direction. It cannot flow through here because it's being cut off. It's going to flow through here, and there's going to be 2 resistors. There's one that looks something like this, and there's 2 connected in parallel. This is a symbol for relay, the coil that we talked about. So if the resistance of the LDR was greater, that would mean that resistance is high, meaning that more voltage is required. Means more voltage here, more voltage in the relay, it pulls it strongly, it acts as a stronger magnet, and thereby it causes a switch to close. Because of that, what does that mean? The circuit is complete and this emits light. Therefore, we would want the LDR to have a higher resistance. That is why the light intensity should be low, because it works in the opposite way. Similarly, over here, different application, we can see that all the current that is flowing through over here, it is going to be carrying a voltage of 6 volts, right? Now this 6 volts need to be divided. So we want to make sure that this part gets the most amount of voltage so that the relay actually works properly. For that to happen, we need to make sure that the thermistor has the lowest resistance so that these guys get more volts, because again, lower the resistance, lower the voltage, that means that the other resistor is going to get more voltage supplied to it, because in some way or form it has to balance it out. I know this might be a bit hard to understand, but if this has lower resistance, that would mean that maybe from the 6 this gets 1 volts and this gets 5, because it has to be distributed equally. Likewise, over here this would be maybe this part gets 1 volt and this part gets 5 volts maybe. Therefore, if this has more volts, it's going to attract the switch, it's going to close it, allowing the LDR to emit light. Therefore, we want the thermistor over here to have the least amount of resistance. That is why B should be the answer, because if you have a high temperature, low resistance, light intensity is low, high resistance. And with that, let's call it a day. If you guys have any questions, do let me know. And yeah, I'll see you next time around. Perhaps I'll be making bio MCQs as well. So yeah, take care.